This video is going to be on basic ground state electron configurations up to atomic number 18, which is argon. The reason why we're not going beyond argon right now is because once we get past argon, it gets a little more complicated, and we're going to reserve that for a second video. All right, so let's talk about some basic ground rules here, okay? First of all, we're going to find that within energy levels, or the shells, there are what are called sublevels, and within those sublevels, there are orbitals, all right? The energy levels, this is like the first one here, and this would be the second one. So the shells are the energy levels. Within those are sublevels. You can think of, Lindbergh High School, let's say, is an energy level. It's got 3 floors. Those are the sublevels, okay? Within those floors, though, there are rooms, and those are the orbitals. But for atoms, okay, we always fill in the lowest energy levels, sublevels, and orbitals first. So when we do ground state, we always do lowest energy first when you write out the electron configurations, assuming everything's in ground state. The second thing you should recognize is as you get to higher energy levels, let's say you go from the first to the second to the third, the shells are actually bigger. So what we're going to find is the third energy level has more sublevels and more orbitals and can hold more electrons. For a general rule there, the first energy level can hold a maximum of 2 electrons. The second one can hold 8, and the third one, okay, can hold up to 18 electrons. And that's because the third energy level has more sublevels and more orbitals, which can hold more electrons. So as you go up, they are larger. Okay, they have more sublevels, they have more orbitals. That means it can hold more electrons, okay? The second thing to recognize is orbitals always max out at 2 electrons, okay? So while there could be 18 electrons in the third energy level, right, that tells you there's got to be a maximum of 9 orbitals because there's 2 electrons per orbital maximum, which means there can only be 9 orbitals in the third energy level. The second energy level can hold 8 electrons, therefore it can only have 4 orbitals, 2 electrons per orbital. And the fourth thing we need to know before we get started here is that given of a choice of an empty orbital of equal energy or a half-filled one, electrons like going into an empty orbital. They don't like being in the same orbital as another electron because they repel each other, and that's a higher energy state. So an empty orbital, it's called a degenerate orbital, by the way, of equal energy is always preferred. All right, so the ground rules again. Electrons go in the lowest energy level first. Higher energy levels are bigger. They have more sublevels and more orbitals. The maximum number of electrons in an orbital is 2. And given the choice of an empty orbital or a half-filled orbital that already has 1 electron in it of equal energy, the electrons will always go into the empty one. Okay, let's talk about just vocab and sublevels and things like that. So these are the 4 energy levels, okay? The first energy level has 1 sublevel, only 1, and that sublevel is called an S sublevel. It has a shape. It looks like a sphere. You don't have to memorize that. I'll show you a video later, okay? It only has 1 orbital, and that's why it can only hold 2 electrons. Now you're going to start seeing a pattern here, so please note the pattern. You don't see patterns, you're not learning anything, right? And the second energy level has 2 sublevels. It has a sublevel called a 2s sublevel. Yes, it has another sublevel that looks like a sphere, but it's bigger, okay, and it's further from the nucleus, okay? And it has a 2p sublevel. Now, the s sublevel still has 1 orbital, but the p sublevel is larger, and it has 3 orbitals. And so what you can see is in the second energy level has a total of 4 orbitals. One of them is an s orbital, one is an s sublevel, and you can think of this as like a house now. And the second orbital house is like, okay, there's 2 sublevels, right? One of them is the S sublevel. It could hold 2 electrons in there. And then it's got like 3 rooms in the P sublevel. And each of those rooms is an orbital. So you can put 2 here, 2 here, and 2 here, which means the second energy level could hold a total of 8 electrons. The third energy level, and again, you might start seeing a pattern, has 3 sublevels. Wow. You see a pattern? Can you guess how many sublevels are in the fourth energy level? I wonder. Okay. Now, the sublevels here are called, it's got a 3s. Notice it's still an S sublevel, but now it's the 3s sublevel, so it's got a different name. It's got a 3p sublevel, and it's got a 3d sublevel. And again, you got the same exact thing here, okay? Right? You got an s sublevel, which contains a single orbital again. One orbital. The p sublevel has 3 orbitals. Now remember, the third energy level can hold up to 18 electrons. So far, we got enough space for 8 electrons. We got to have enough space for 10 more electrons, which means 5 more orbitals. The 3d sublevel, okay, that sublevel, okay, can hold up to it's like a floor with 5 rooms on it. It can hold 10 electrons because it's got 5 orbitals. So it can hold a total of 18 electrons because there are 9 orbitals total. Right? Add this up. This is 9. Okay, maybe you can fill in the fourth one with me. Okay, and you should see a pattern here. Ready? How many sublevels? 4 of them. A 4s, a 4p, a 4d, and a 4f. Okay, this is 1 orbital. This is 3. This is 5. Can you guess? That's right, 7. You add that up, okay, you get 16. There's 16 orbitals in the 4th energy level. 16 times 2 is 32. It can hold 32 electrons. All right, now we're going to write out standard electron configurations for 3 elements. And I'm going to go kind of slow here, okay? And these are ground state. Maybe I'll show you an excited state just to make that a little bit interesting, but let's do this first, right? Here we go. So I got 4 elements up there, and I'm going to put the atomic number. Now, we're assuming these are neutral atoms. These are not ions. I could do an ion if I wanted to, right? Now, oxygen has atomic number 8, neon is 10, sodium is 11, and argon is 18. Now, I'm going to do oxygen nice and slow. It's literally a notation. It's like you're learning a language, okay? Now, you fill in the lowest energy levels first, okay? Now, let's go back here a little bit. Okay, I want to make sure you're clear. A 2s electron has less energy than a 2p. You fill in 3s before you fill 3p. Okay? You follow? So you're going to fill it up in this order. Okay? This is low energy. This is high energy. The reason why I'm stopping here is once we get past there, we have more than 18 electrons, and some of the stuff in here gets mixed up. And because of that, you're going to have to use the periodic table as a crutch, okay, as it were, to figure things out. And I'll show you how to do that in a subsequent video. That's why we're stopping at 18. All right, I'm going to write out oxygen. Oxygen has 8 electrons. It first puts the first 2 of them in the first energy level. Now I'm going to write that 1s2. It's a language. Oxygen has 2 electrons in the s sublevel, in the only orbital of the s sublevel in the first energy level. This 1 is the energy level. This s is the type of sublevel and orbital. So there's 2 electrons in there. The next thing, now at this point I've used up 2 electrons, so I start with 8. I now have 6. The next place I put them is in the 2s sublevel, which has only 1 orbital, and it can hold 2 electrons. Now that's a total of 4. I'm down to 4 electrons remaining. Where do I put the remaining 4 electrons? In the next lowest energy, which is the 2p. But I'm not going to fill it up. That p sublevel can hold 6 electrons because it has 3 orbitals. So I'm going to put them here, like that. And that's my ground state configuration. If I were to draw this as excited, I'd be like 1s2, 2s2, I could do like 2p3, and then I could put one in like, say, 3s1. Okay, which means instead of filling up this p sublevel, which can hold 6 electrons, I bumped one up to the 3rd energy level in the s sublevel in its orbital. Okay, let's try neon. Now the good thing is it's a pattern. It's always the same, right? Neon has 10 electrons. The first thing it's going to do is put its electrons in the 1st energy level, which can hold 2 electrons and has an s sublevel. So neon's going to start the exact same way, 1s2. It starts out with 10, so now we're down to 8. The next thing it's going to do, put them into the 2nd energy level. First thing, 2s2. Okay, now we're down to 6 remaining. Where are we going to put those? In the 2p, 2p6. Now that's 10 electrons total, which means neon, a noble gas, has a complete 1st energy level and a complete 2nd energy level. That's going to be significant. We're going to find out that leads to special stability. And that's why neon doesn't bond. That's why it's a noble gas. That's why it's always a monoatomic element in all our problems before. Sodium is different. Now, sodium has 1 more electron, which means it's going to start off the exact same way. You don't have to rethink it. Here, It's going to start off this way. 1s2, 2s2, 2p6. Now, that's 10 electrons. 2 plus 2 plus 6 equals 10, right? We have one more electron. Where's it going to go? It's going to go up. It can't put any more in the second energy level. It's filled. It's got 8 electrons, right? So we put in the third one. Where do we go first? 3s. How many to put in there? 1. Now let's just talk about this. Sodium, if I were to describe its electron configuration, right? How many energy levels are occupied? The first is occupied. The second is occupied. The third is occupied. Sodium has 3 occupied energy levels. How many energy levels are completely filled? Well, think about it. Is the first one filled? Yep. Is the second one filled? Yep. Can't put another one in there. It's got 8. Is the third one filled? No. It's occupied, not filled. That bus has more seats on it, right? So sodium has 2 completely filled energy levels. How many completely filled sublevels does it have? Well, this has sublevels completely filled. This is completely filled. It's got 3 completely filled sublevels. The 1s sublevel is not the same as the 2s. Those are different sublevels. Yes, they get the same letter because they look the same. They're the same 3-dimensional shape, but they're not the same. They're not in the same place in space. Right? They're different locations of probability. Let's do the last one, argon. Okay? Now, argon starts out the same exact way. So I'm just going to redo it again. Boom, that's the first 10. We have 8 to go. Right? Next thing we do, 3s. How much can the 3s hold? 2 electrons, 3s2. Okay, we got 6 to go. Right? Where are we going to put them? In the 3p. How many electrons can a p sublevel hold? 6. Boom, we're done. That's the electron configuration of argon. Argon has 5 sublevels filled. 2 energy levels filled. 3 energy levels occupied, because the 3d is not filled, is it? So the third energy level is not filled. It's got 2 electrons in the first energy level. It's got 8 in the second energy level and 8 in the third. And if you go to your reference table and you look up the shell configuration, right, you can figure out the shell configurations from these ones. For example, if I do oxygen, oxygen has 2 in the first energy level and it's got 6 in the second energy level. Matches up with the periodic table, doesn't it? Neon, 2 in the first energy level, 8 in the second. Matches the periodic table. Sodium, 2 in the first energy level, 8 in the second, 1 in the third. The shell notations are shorthands for the more complicated electron configurations.